This is our snake, and the snake has two types of scales. Dorsal scales and are the top scales, and ventral scales are the bottom scales. The scales are made up of cells stacked on each other, and the most outer layer of the cells is dead cells, and snakes shed that a couple times in a year. Snakes have tough skin and provides a sensory function. In some snakes, the frictional resistance is a crucial component to its locomotion and movement. And the skin is covered by scales for protection, and the skin is compromised by two major layers that are the epidermis and the dermis. These orange things are fat bodies, and they help the snake store energy.
As part of the digestive system, the snakes also have a gallbladder, and it stores bile in this yellowish-brown fluid that's produced in the liver and released into the small intestines to break up the fat. The gallbladder is connected to eating meals, so as a snake only eats like once a month, it has like a huge gallbladder compared to its body, compared to humans who eat like a few meals. And actually, animals like zebra and deer who graze all day don't have gallbladders at all because they don't need it because they're constantly eating. It's difficult to find the gallbladder because the snake just ate recently, so the gallbladder would have released the bile into the intestines. But it's right here, right after the liver, so then it goes into there and then into the intestines. In the respiratory system, the trachea is really crucial because it's also their windpipe. And on the trachea, there's cartilage rings that will support the air passageway into their lungs. Because as a snake is eating, it swallows its prey whole. So as the prey goes along this digestive system, all the organs are pressed up against the walls of the snake. So in order for the air to get to the lungs, there has to be support, or else the snake will suffocate and die. It's here, into the heart, and the heart will bring the air to the lungs.
So looking at the snake's tongue, we know that the main function is to be used for smell. So by constantly flicking their tongue in the air, the snake is able to pick up odor-causing particles in the air and deliver them to the sensory organ inside the mouth in order to detect those smells. So the split tongue lets them smell in three dimensions. So by picking up the particles from all areas in the space, it helps detect the location of the source of the odor hormones. So for an example, the snake can smell pheromones in the air to detect other animals that are their prey. Located behind the nose, there is a Jacobson's organ, which is a sensory organ that collects the particles that are collected by the tongue. So when the tongue is flicked up in the air, it delivers them back to the roof of the mouth. And that's how the particles then go through like the nervous system, and the snake is able to detect all of those smells around it. So looking at the snake's lungs, while humans have two fully developed lungs, snakes only have one on the right side. Some species do have two or even four lungs, which is just a semi-developed lung on the left side. And then the others would have an additional pair of premortal tracheal lungs located beside the throat. So within the right lung, snakes have two separate chambers. The first is the same as humans, but the second is an air sac. And then the air sac acts to holding oxygen while the snake eats. That way they don't run out of air while they're eating. So while average humans can hold their breath for 3 minutes, a snake can hold their breath for up to 2 whole hours.
Snake is a female because from the cloaca to the end of the tail, it tapers pretty evenly and just like consistently. And then when you look inside, there are eggs inside, close to the intestines and reproductive system.